Okay, so you have seen the announcement. Tomorrow at 10 o'clock, I put a session online. Anybody wants to have any questions about midterm, you can ask me then. Um, and that's that. So join tomorrow if you have any questions about the midterm. The rest of the stuff, it's already in the agreement. So take a look at the agreement. You're going to see exactly what questions are going to be there. And I'll give you a practice test so you can do the practice test.
Sorry, sir. Your voice is unclear.
Can you hear me? Hello?
Yes.
Okay, is it better now?
Yes.
All right,
Thank you.
no problem. Okay, so that's that. And let's set this one to the same thing. Actually, it looks it's okay. Anyways, we'll find out. So today we are going to learn how to rap. Not to rap, but to, So I'll explain in a moment. Okay? So let me write a piece of code first. So we make this thing ready for those who logged in from home. Uh, uh, this is not an electronic classroom, so you are on the side of my screen. So if you have any questions, anything. Today's thing is going to be that we're going to talk about wrappers, understand how they work, talking about binding, talking about operator classes, learning those things. We're going to jump into algorithms, and that's going to be the end of it. Okay? Um, yeah, that's it. So So let's say I have a vector of integers, v, and I'm going to set it to 10, 20, and 30. Or no, let's do it like this. I'm going to have integer a 10 and b 20 and c as 30. Now I'm going to say for auto reference I in v. And in here, I'm going to say C out I. And I'm just going to add 20 to I. And after this, as I'm going through it, so first I'm going to display it, then I'm going to put A and B, add 20 to each one of them. As you see, it's by reference. So if I do another for each in here, that's going to show the values in the vector. Okay? And
For that, we cannot hear you here. The sound's not audible.
What can I do in here? 1, 2, 3. Is it getting disconnected or something? One, two, three, four, five. Can you hear me? Can you hear me at home?
Yes.
Okay, I don't know what's going on. I hope that these things are going to work properly, but remember today is an in-person session, so please, this classroom is not equipped for all these things. If it's very possible that it's going to go bad again. Again, keep telling me and we'll see what happens. So one more time. So I am printing every element of the vector. It's by reference. I add 20 to it, then I'll go through it again. And then after that, I'm going to display A, B, and C and see what happens. Okay? So in here, I'm going to go C out A, B, and C. Okay? And let's run it again. Okay, so as you see, 10, 20, 30, oh, I need to go to new line over there too. The point that I'm making over here is that vectors keep things by value. If you see over here, the vector V has value A, B, C. And when I show the values in vector, they are 30, 40, 50, which means the values were actually added to each element of the vector. But A, B, and C are untouched. And it's not going to change anything. It's not going to change it over there. So what can I do? Can I create a reference? No, vectors cannot hold references. They are by default, all the containers are created to keep values. They cannot hold references. References must be initialized. You cannot set them to anything. So what do? Let's create a class. I'm going to call that class a wrapper. It essentially wraps things around other things and gives us access to them. So essentially, you'll see what it is. We'll go through it. So, and I'm going to make this a template. So I'm going to say template, type name, type. And I'm going to say this wrapper of mine is going to have a type pointer that is the data that it's holding. So its job is to hold address of something. And what do? I'm going to say, okay, let's instantiate this. So I'm going to say wrapper. And in this wrapper, I'm going to get a reference of the same type of data. Then what I will do, I'm going to initialize the mdata, that is the address that I have, to the address of the data that is coming in. So what happens over here is that mdata becomes the address of the data that is coming in. Are we okay with this? Then I'm going to say, let's do a type conversion over here. So I'm going to go operator type reference. And I'm going to return target of mdata. So what did I do over here? It's not a fancy class, very simple, right? So this class holds the address of any reference that I pass to it. And if somebody wants to know what the reference is, it sends the target of mdata, which is essentially the reference of what I'm holding. So essentially, this wrapper is wrapping the reference of anything that I am passing to it in an entity. So what happens if I create a vector of this? Okay, So this wrapper of mine, I create a vector because the class wrapper is essentially a type, right? It's something that I can create it with. And then in here, I'm going to say, let's call this W. I'm going to put A, B, and C. So what happens over here? My wrapper vector will get initialized by A, B, and C. Right? So what happens? Essentially, it will be set to the address, to the essentially references of ABC. So that wrapper of mine essentially wraps the reference of ABC. So now if I do the exact same thing that I have done with the other one, so instead of V, I'm going to put over here W and W. I think I had one more. So this is, so in here, it's going to be C out the wrapper. So now it comes over here. It creates the two vectors. One is ABC by value. The other one is the wrappers of ABC in a vector. Right? So this, we know what happens. It goes, all three of them are set, all three of them are printed, and this is what happens, right? Now, take a look at here. This one I'm saying add 1 to the I. When I say plus equal I is of type wrapper, correct? Because I set it up to return the reference of the type when it's casted, when it's needed to be casted, the compiler sees at left side of a wrap, at right side of an int. And he says, what can I cast this to so this thing makes sense? What? An integer reference, right? Therefore, the target of what I is will be added by 20. If I go through the vector, obviously they are all set. But the interesting part is that if I go to the ABC, those are changed too. So I successfully copied references of variables inside a vector. These type of stuff are called wrappers. Don't worry about it. You don't need to create it. They're all there for you. And we're going to start going through them one by one. We good? All right? So just wanted to show most of the stuff that you see in the library that is created for you, they are not very complicated code to create. They are very simple things. It's just some smart guy thought about it and created it, right? So let's go through it and see what happens. Okay, so this one, I'm going to call it A1-wrapper. So essentially, if I want to define what a wrapper is, here I am wrapping anything, any value. And I'm saying get value returns the value, set value sets the value, and display displays it. It's an OOP345 thing. Very simple thing. It is a wrapper too. It doesn't serve any purpose. I'm just wrapping something and I get the value and I set the value. But the point is that a wrapper class template in C++ is a class template that acts as a container or wrapper around existing data type. That's extremely for us important to know. Okay? It will be used to add additional functionality to the type. It wraps without modifying the original type and just gives you access and functionality and control to it. That's all about it and nothing else. Okay? So all the wrapper classes can work with any data type. It's designed that way. They are reusable, which means the same wrapper can be used for different types of objects, and you can add more member function and functionality to the wrapper without modifying the type. So the type is there, you just add, like, remember that I created that integer thingy to show you different types of functions? One was with a lambda to validate it, and I called it validated an integer. That's a wrapper. I created a wrapper for an integer that added validation functionality to it. And you can use that thing. So if you change that one to a template as I asked you to do so, and you imply all the validation functionality stuff to it, you literally created a perfect validator wrapper around any type. Okay? Now, by now, we understood, and we know that for a fact, we can actually keep functions, function addresses using their names, right? But for every and each, we have a different type of thing. One of them is a function pointer. The other one is a lambda. And the other one was a functor. So we had 4 different types of callable functions, 3 different types of callable functions, right? So let's say I have a simple function that says hello. Okay? And I have another function that adds 2 values. Okay? So what I can do, I can actually create a wrapper to wrap that function inside an object so I can pass it around. So I can literally say, so this one is a void, right? It doesn't, so I'm going to say, and it isn't functional, so I essentially say function, void, and I do this. It means I want to create a function of type void, and you know that's a type of a function, right? We create functions. I said if you take the name out, that becomes the type of the function. So that's the type of the function that we have, right? And in here, I will call this thing and I will set it to say hello. So now say hello is wrapped around with this. And if I want to call that one, I can use the function wrapper 1 and call say hello. It's the same thing like the other one. No difference. Okay? What is the difference between this and the other one? Is that I don't have to care what type of a function that say hello is. Any callable function with that signature can go in that wrapper. I don't need to create a functor for it. So if I want to create a validated integer, instead of saying this one is created to work with lambda, this one is created to work with function pointer, this one is created to work with functor. Instead of all that, I just put a function wrapper with the signature of the function in there. And any type of function being passed to it will be accepted. The exact same things that I mentioned to you when I was talking about what essentially a wrapper is. And now I can create a function int wrapper too, and I put the add in it. And they all work seamlessly, and I can actually use the function wrapper to call that one. Remember, these, you will see soon that we're going to have algorithms. And algorithms are, I'll explain exactly what they are. Exactly like the integer thing that we created, that it needed a function to know what is the logic of validating an integer, algorithms need a function to do something so the algorithm happens. So the heart of algorithm, like when you are doing the sort, the heart of sorting is comparing two things, right? So that's what you do. You have a sort algorithm, and you just pass a function to it that compares the two side-by-side element, and it does the sort for you. Okay? We'll go through it in a second. Okay, so functional library in C++ includes a class template called unction. No, that's a function. Sorry. Okay? Which acts as a general purpose type erased wrapper for any callable entity. When we say type erase, it means it doesn't matter what type of a function it is. As long as it matches the signature, it's fine. Okay? This wrapper can be used to store and invoke functions with a specific signature, as you see over here. Just want to make sure it runs. This is just an example to show you that it doesn't matter what do you have. If you have a lambda expression, it's the same business. No difference. Now, this lambda is doing the same thing that add did, right? Exactly the same. No difference. It's a lambda. I'm putting it in an exact same function wrapper, and it works perfectly. Take a closer look. So I have a lambda that receives two integers and returns the sum. Then I'm going to say func int function returns an int, receiving two ints as arguments. That's my function wrapper, receives the lambda sum, and it works perfectly with it, even though it's just a lambda expression. And the exact same thing with a functor. So this functor multiplies two integers, right? The signature is exactly the same, no difference. But I'm using the exact same wrapper to keep the multiply as when I put parentheses in front of multiply, what does it mean, by the way? Anyone? Why did I put parentheses over it? Huh? No? Remember, that's the name of the class, not the object. If I did this, this is a function call. But here, it is a constructor, right? So essentially, by doing that, I'm creating a nameless functor and pass it to funcwrapper. So funcwrapper will wrap that nameless functor whose signature is int, and returns an int. And therefore, it works. So as you see, it doesn't matter what's in front of it. If it's a function pointer, if it's a lambda, if it's a regular function, essentially a regular function is a function pointer, or it's a functor. They all work perfectly. We good? Okay. Hence, the wrapper. Okay? Yes. Mm-hmm. I'll bring it in a second. Yes. Find the operator overload for function call that matches the signature. So if you had something like this in here, then it would pick up the top one, not the bottom one. Okay, the one that matches. But let's not confuse it with the point that I want to make. I just don't want to make it confusing. So we're okay with this? We'll see soon what these function wrappers are used for. Which brings us to this. And I have that text at the top so you know exactly what I'm talking about when we are writing this. So this essentially is 3 different type of functions. They are all void, you see? Hello, hello, hello. And I have identical function wrappers putting 3 different things in it. And it just works perfectly. I could have made an array of function wrappers and put them one by one too. It doesn't make any difference. But they are all working the exact same way. And that's called type erasure. Why use it? Please go through this. I've written this thing over there for you to read it and see why we have to do it. Okay? So I'm mentioning over here the term type erase refers to programming concept where the type information of the object is hidden or erased in such a way that the object's type is not known at compile time, but still can be managed and called at runtime. Got it? As long as the behavior is the same, we don't care what is the type. And that's what we need. Okay? What else? Oh, yeah, actually this is very important. One thing you need to know about function wrappers. No matter what you do, you are creating an object that is handling another object. So you have a middleman over here. That causes overtime, or that causes, just a second. No? That's the worst feeling. Okay. All right. That creates overhead. Okay? Yeah, that creates overhead. So using a function wrapper is kind of it has many benefits, but remember that it causes a bit of overhead. Yeah. That's it. Yeah. Anyway, so yeah, so when you check the type, when you cast the type as is, it returns, essentially, did you remember that I had a pointer in there? If I set the pointer to null by default, then I casted it to a Boolean, then when I could actually return a false when the thing, so let me just bring it up. Sorry. So I forget it. I'm not going to change that one. But just know that it is overloaded for Boolean cast, and it tells you if it's an empty function or not. So you can see if a wrapper is actually pointing to something or not. Okay? And this is what I just created, and you already have it. So because I wrote the code, it's not very difficult to go through it very quickly. So it's called reference wrapper. Essentially what I wrote You see it here. Okay? It has more bells and whistles. So if you can go .get, it actually returns the reference of what you have. Okay? So reference wrapper's job is essentially to do the same thing that I did at the beginning of the class that I did a wrapper. It does the same thing. So essentially, reference of A is that one, reference of B is that one, and you can call the get. Get essentially returns the reference of what you have. As if I had a get method in there returning star.data. Okay? So that's standard reference wrapper, and it is in functional. And I have no idea why I have vector in here. Okay, so keep that in mind. Why did I call it D? A, B, C, D, E, F. Yes. You can. It's a class. Nobody's going to tell you don't inherit something from it as long as you know how it works. Any class in C is like that. Any class. You can inherit something from OStream and do something with it if you want. So any class is like that. If they don't want it, then they make the constructor private and they won't let you do it. So try it and see what happens. But any class you should be able to. But again, it's all if they want the design to be final, they will make it in a way so you cannot do inheritance from it. I haven't tried it, but possible. Try it. See if you can do it. So yeah, that's good to know. So wherever you have a reference, wherever you have a what does it say? Didn't I add? Oh, using namespace std. Wherever you have a reference, you can pass a reference wrapper instead. It is overloaded for it. So if a function is receiving a reference, you can use a reference wrapper instead. It works perfectly. It is overloaded for it, and you can use all the benefits of a reference exactly using a reference wrapper with no problem. Okay? And this is the explanation for it. Please go through it. Okay? Yes, so EFG reference wrappers are overloaded as to work with reference. Okay, this is the exact same example that I gave you with the wrapper I wrote, but it is using the get method of the reference wrapper that we have in C++. So essentially, I'm creating a vector of reference wrappers of integer, and I'm putting x, y, z over here, and we use get to increment the target of the reference wrappers. We good? All right, so this get essentially returns the reference, so you can put it at the left side. And you want to, I don't know, but it's pretty obvious. It's the exact same thing. The only difference is that I'm using the get method of the reference wrapper. Okay. There we go. Now the cool part. Okay, so say you have, let me remove this from here. Say you have a function called greet, where you pass a name and a greeting, and it greets the person, right? So what if I want to greet John only? What do? I can overload, create another greet with one argument, and then so I can do this. So I can write over here constant string greeting, right? Now I can call the other greet. I can say greet John and greeting, right? I can do this to only greet John, but we don't need to do that because of what we have in C++ to bind a function call to another signature. So what happens, it creates a function object. So let me show you what happens. So I'm going to say over here int so I'm going to say auto greet John, and then in here I'm going to say bind greet with John, and for the other one put a placeholder for argument 1. So what happens over here, it means greet John becomes a function object who will call the greet passing John to it, and the only argument that you're going to pass to it will be this one. This is a placeholder for that one. Therefore, greeting's got to be passed to it. So you can actually do this. And why we do this? Why am I getting an error in here? What did it? Oh, sorry. My cheat sheet is misspelled. Okay. So now, why we do this? Why do we do this? Say you have an algorithm that requires a function with a specific signature that you don't have. Your function has more arguments and does more stuff. You can pass that function, change its signature using bind to what you want, and pass it through to the other one. So you don't have to rewrite the function or create a new function. Does that make sense? So bind essentially does that. Okay? So you can create functions object with a sub-signature of any other function that you have. Okay? That's binding. Yes. Placeholder 1, it means this. If it was another one, I could have placeholder 2. Essentially, it says I'm holding a place for this one. If I put over here, hello, then greet John will only accept no argument. It would be 0. It will be just greet John, and it will always say hello, John, hello. Yes. Replace holds a space for the argument that is coming after the one that you actually filled in. Yes.
So have a function that had like sense and like let's say name and
Yes. Yes.
you put in the bind on and then you wanted
The middle one and then placeholder and the other one. Yes, you can. Yeah. Yeah, no. Then it will be placeholder 2. It essentially, as you just number your placeholders and it replaces it. So they are not exactly the same. Yes.
So, for example, placeholder double column and lower the number of placeholders to use. For example, 6.
Yeah, and it keeps going up to the number that you have, to the number of arguments that you have. Yeah. Okay, so that's that. That's bind.
Similar to alias /.
Yeah. Programming languages are all similar. Let me pause recording for a second. Always. So this is with 2 placeholders. Okay? So now I have placeholder 1, placeholder 2, and I am telling you how many times I'm going to do the greeting. Okay? JK bind with multiple placeholders. Please read these things that I have written before this, because I know questions are going to come up. And initially, I used to quickly put all these things and say, go study yourself. But there are so many that I cannot keep up. So I put all these things, and what I want to say in class, I write it over there. Please go over it and read it. Yeah. And this is actually not important. I'm not going to put this up. Absolutely useless to do something like this. To create, you see this greeting thingy? Like I said that instead of binding, you can use lambdas. So instead of writing greet John, I'm going to say greet John and then create the thing that I want, and I'll call the other one. It's exactly like I did with a function. I created a function and called the other function in it. With lambdas, many people do this, but what's the point? The whole idea of bind is not to create something new, okay? Lambdas kind of fit because they're only in this scope and they don't exist after. So there's it is a solution. You can actually use it, but bind is easier, I think, okay? So in here, I'm going to say lambdas instead of binding. So there are functions that create reference wrappers for you. They are binders that create reference wrappers for you. They are functions that create reference wrappers for you. Take a look at this. What did I do? Okay. Give me a second. So in here I have increment, and increment is receiving a reference. You see that? Bind cannot pass a reference. Bind is exactly something like vector. It only works with values. So if you want to bind a function to something with a reference, you have to pass its reference wrapper to it. But it's too difficult to create a reference wrapper and put it. So they create a function that you pass a value to a function, and in return, it gives you a reference wrapper of that. Therefore, a reference wrapper of value will be passed to increment, and therefore your incrementation will work. Do I make sense? Completely confusing? Okay. Bind only accepts value. You cannot pass references to it. Number two, what if I have a function that receives a reference as an argument? What do? We learned we can create reference wrappers. So either you can create a manual reference wrapper to, actually no, you can't. Oh yes, to the value that you want to pass to the bind. You see that? Either you have to create a separate reference wrapper and pass that one, or if you want to just pass a nameless reference wrapper, you can call ref. Ref essentially creates a reference wrapper for you for the thing that you are passing and returns it. Therefore, remember that we had it before. Remember I said we had ref, and I said I'll explain it later. I don't know. I cannot explain to you what the ref is because we don't have enough knowledge. That's what it is. Ref returns a reference wrapper for an object and passes it along, so when it's received by a reference, you can change the target. It's not by value. If I just put the value in there, it's not going to increment it because it passes the value to it. So that's that. Anyways, so yeah. So, and we have two different one of because sometimes you have constant integer reference. Now, constant integer reference need a constant reference wrapper. Therefore, they created. Remember, I told you they saw that it doesn't work. They added stuff. It's one of those. So if you write cref creates a constant reference wrapper, where ref returns a regular reference wrapper. Okay. Pardon me? Oh, but when you get used to this, believe me, this is the simplified one. Because we have learned to do everything manually. These things look complicated. But as soon as, again, I'm going to pause the recording. Ref and cref. Ref and cref. Last but not least, say you want to have an algorithm called accumulate to find the sum of all the stuff, okay? And so you have two choices. Either you have to write a function called sum that does it for you, or you want to just pass the operator plus. So plus means, when you do plus, it means sum, right? So what they did, they created function wrappers, functors, for every single operator that we have. So you can actually pass those instead. Now take a look. When you look at what we have in it, so take a look at this. Multiplies double mul. So what mul will do, essentially multiply two doubles. It's a function that multiplies two doubles. So if I want to say A is equal to B multiplied by C multiplied by D, essentially I have to multiply A by B and then multiply that. This is called functional programming. Okay? So this multiplies is the equivalent to multiplication. And I know it for a fact that we have it somewhere in the notes. They listed all of them. Okay. Okay. Trust me, it's in there. Please go to go to the lecture that we have. I think it's functions or functional. I don't know what is the name of it, but seriously. It's there, trust me. Okay, please take a look at it later on, and it's all listed over there. I'm going to let it turn over here, and hopefully soon it's going to come up. Okay, so we have multiplies, we have add, we have all the operators in there. Okay, and it's in functional. Okay, so the part of the note that talks about functionals, it's all listed in there, so you know that. So that's they're called operator classes. And now let's take 5 minutes break. I think it's loading. It turned to black. Okay, so let's take 5-10 minutes. 5 minutes break and come back. Okay. 5-10 minutes. I'll pause. Please remind me to resume. Okay, so let's talk about STL algorithms. So the standard template library algorithms, they are a collection of pre-written functions that operate on containers like vectors, lists, and maps, and set, and stuff like that, but not directly through iterators. So essentially, algorithms work on containers through iterators. Okay, that's extremely important to know. They are generic, they are reusable, and they are optimized for performance, which means when you use them, it's highly unlikely that you can write a faster code than what an algorithm can do for you. They came in 1990s, okay? Before that, there wasn't there. So C++90 didn't have it, and then it came afterwards. Essentially, they created these algorithms to separate data, algorithm from data structure. Anybody knows what is the difference between the two? The data to process. So essentially separated the logic from the processing data. So no matter what type of processing data you have, collection of processing data you have, you can give it to an algorithm, and the algorithm will execute what you want to do on those. Their purpose is to simplify searching, sorting, transforming, accumulating, and all the good stuff. They provide functional programming style, which is essentially the multiply that I wrote. Okay, so you pass functions to them, they work for you. Okay? They operate on iterators, not the containers. This allows flexibility because iterators are completely generalized. So essentially, any iterator you create to any type of container work with the algorithm, and that is ultimate polymorphism. Essentially, what they have, they get the base class, the interface of an iterator, and they use their functionalities. And because each iterator is derived from the master, the base iterator, therefore, it works for all containers. If you extract an iterator out of a vector, it works with a vector. If you extract an iterator out of a list, it will work with the list. It doesn't matter, because it's the iterator that deals with the algorithm, not the algorithm working with the container. Okay? They are optimized for runtime performance, and they are highly efficient in implementation. So why we should use algorithms? Number one, faster than manual implementation. Anything you can do. You are writing less code, much, much less code when you use algorithms. If you learn how to use them, you don't need to write the code anymore. The code is written for you. All the complex algorithms are written for you. And believe it or not, they improve code clarity. Okay? It looks like cryptic stuff now, but as soon as you get used to it, it makes your life much more beautiful. Okay? Examples. I'm going to start with simple ones, very simple things to go through, and then I'm going to give you a bunch of nice stuff to look at and go through. For example, if you want to find something in a vector, what do? You put your stuff in a vector, and you write what you want to find, and it finds it for you. How does it find it for you? Using checking for equality. So if the vector that I had over here was a vector of employees, and I want to find an employee with a specific employee number, all I needed to do was to overload the equality operator, the comparison operator, two assignments, okay? To overload that one, and with an employee ID, and put the employee ID over there, it will find it for me automatically, okay? And what it essentially does, again, you pass the beginning, iterator to the beginning, iterator to the end. It knows exactly where it's going to be, and it returns an iterator for you. If that iterator is not end, it means it found it. As easy as that. So much quicker and easier to actually write an algorithm to find something for you. Okay? And it finds the first occurrence of the thing that you want inside the, yeah. And later on, forget it. Well, later on, I'm going to talk about it later. So this is algo. LMNOA. Algo find. Binary search. Who knows what's binary search? Anybody knows it? Knows what binary search is? Binary search is when you are searching through stuff that are sorted in an ascending order. So if you want to actually look, have you ever, like when you are looking in a dictionary to find a word, what do? You open the dictionary, the word starts with, I don't know, A, not A, like C, okay, or F, starts with F. You open up the middle and you see it's N, so you know it's lower, right? So you get the other half, you open half, and you see what it is. You see it's G, so you know it's smaller, okay, EFG, right? So you open the middle, and in the middle you see it's D, so you know it's between. So you keep going half, 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 until you hit it and you find it. That's the fastest search you can have. It's called binary search. This does it for you. So you do binary search and you say what, and it finds it immediately for you. Okay? As long as it's sorted. Now, what is the best container to use for a binary search? I taught it last time to you. I taught containers to you, right? Different examples. There was one container that no matter what you did, it kept everything in order. What is the name of that? No? No, map is completely out of it. It was a set, right? Okay, and yeah. Okay, so anyway, so no matter how you did it, does it. So if you do it like that, it's going to find it much quicker for you. Anyways, so that's that. So this is OB, and this is binary search. Sorting. And these are all standard. We are not passing any functions yet. So if you just use the algorithms as they are, they do standard checking. So when you are doing sorting, how can you find out if something's greater than or equal to, greater than or less than the other thing? You need less than, greater than, overloaded for it. If they are overloaded, it will sort it for you. You don't need to provide any type of functionality. Okay? And that's that. So it actually sorts everything for you like that. So you say sort from the beginning to the end. So essentially it rearranges the elements in the range that you are giving it to it in an ascending order. Okay? Extremely optimized. OC, and that's sorting. Modifying algorithms. Let's say you want to multiply, double all the contents of that vector, one by one. What do? You say transform from here to here, put it starting from here, and apply this function to it. So this could have been another vector, but you can place it in itself too. It doesn't matter. Okay? So essentially, I'm saying start from the beginning, go to the end, and put the values here. I could have something like I could have created a vector with the same size, and I would say over here, put it in the result. It makes the same thing, no difference. So I'm saying start from here, up to here, put the results here, apply this to every single thing. Okay? Pardon me? Nums, it's not transforming nums. It transforms the iterators of num into result. Okay? Yes. Yes, in previous one, it would have changed num itself. But because last time I put this thing on and everybody was confused, like why we have nums everywhere. So it could be that or this, okay? It doesn't make any difference. You could have, so we can, so I'm gonna say over here. Changes, triples nums, doubles nums into res. Okay? Actually, forget it. We'll talk about that later. I'll show it to you. Too many things now. I wanted to say that actually you don't write a loop anymore. There is an algorithm called for each, okay? So you can actually write an algorithm. It's more efficient than a loop. So you can actually write an algorithm. We'll talk about that later. It's just. So this one is going to be transform. O, A, B, C, O, A, B, C, D. Okay, so transform. Another example, replace. So it searches for all occurrences in 2 in here and replaces each of them with 9. That's another thing. So again, there are so many things that like I'm giving you just different examples to run through to see what it is. Things that I think that might be interesting for you. What else? Count the occurrences stuff in a set. So it counts how many. Oh, that's not the one. Sorry. Turn off your cell phone. Who was that? Okay, so count, okay? So what count does over here, it goes from the beginning to the end and counts how many 2s you have over here, and it returns a count. Yes? No. I don't know. I don't think so. It has a third, and I don't think it does. No. No. And again, if I wanted to find all the people that had 3 children, then if my person's number of children was overloaded with an integer returning true for whatever, it would have worked, okay? And also we have a count that receives a function wrapper here too. So you can actually write functions that return true, and that true will do it for you. We'll see in the next example. These are simplest way of calling algorithms, okay? Count. Accumulate, add everything up with an initial value, and that's accumulate for you. If you want to add the sum of everything, and this is the initial value, it starts from 0. So adds up everything, okay? And now, let's do this. So, I have an employee, as you see over here. Has salary, employee number, yada, yada, yada. I have the comparison set to check to see if the names are, so if you compare an employee with a constant character pointer, it returns true if the name of the employee has that subname in it. Got it? You okay with this? I have operator greater than with salary, so you can compare an employee with a salary, and that's going to happen. If you compare the employee with another employee, the names are going to be compared. If you cast it to a double, salary will return, and you can print it. Are we good? I have lots of employees in here. I'm creating a double vector called taxes to the size of employee, and I put 13% in each. I am creating a double vector owing, how much money they owe. And I create an employee iterator over here, and I call it IT. Are we okay with this? All right. First of all, we show all the employees, as you see, one by one. We'll go through them, right? So this, let me actually run it as we are going through it. Okay, so employees created, it comes over here. All the vectors are created for double. These are the employees. It goes through them. One by one, it's going to show all the employees. Are we okay with this? All right. Run to cursor is Control F10. Control F10, remember that. Okay. So it comes over here. Now, I'm going to put in name Mindy. Okay? Now I'm going to say find from beginning to end name. Remember the find that I had for integer? This one is an employee and name. But because the equality is overloaded, it's going to send the iterator back, and I know that's Mindy Simmons. I think it was Bart's girlfriend. Anyway, so that's that. So found at the position, what position? I can either use distance, or I can simply use minus between two iterators. So if I say current iterator minus beginning plus 1, it returns the number of steps he has to take from one to another and returns that one. So you know it's in the 16th position over here, Mindy Simmons. You good? All right. Now we're going to actually count the number of people who have Chip in their names, and there are 3 of them. Okay? And I'm saying count if. So the other one was count, right? This one is count if. When you say count if, it needs a function wrapper that returns a Boolean. If that function wrapper receiving the iterator's type returns true, it will add 1 to it. So I want to find how many of the employees have salaries more than 80,000. Just imagine for every single thing, and really think about it for a second. Let's say you are writing a program who wants to go search through the whole thing and find out how many people are making more than that certain salary. You enter the value, you pass it, and you just call one function, and it finds everything for you. You don't have to worry about it, okay? So these are the number. Now I'm saying transform from the beginning to the end of the employees into taxes. Applying taxes, okay, with the operation of double, putting it in owing. So transform, this is another version of transform. You give the range that you want it to operate to. You are telling what to apply to every single one and where to hold the result. And you give it a function. So essentially, it multiplies the tax to the employee as a double and puts it in owing. Because I casted the employee to a double in here, it will return its salary. And therefore, everything's going to go in owing. You're going to see how much they owe, actually. And if I want to show them all, I'm not going to write a loop. I'm going to say for each owing beginning, owing end, double val. So essentially passes every iterator of this one to this lambda and prints it out. So it shows all the values. These are all the amounts that are owing. I can sort all the employees, and I can show them back again. I could have done this with a for each too, but I didn't. So, and it's all there. Are we okay? All right, so that's better. There we go. Yes. Pardon me? Sort from the beginning to the end, and a function that compares the two employees and returns true or false. Whatever it could be. You could do anything you want in that function as long as you return true or false. Now, I happen to use the greater than sign. You don't need to. You could compare their salaries, do whatever you want to do that you want to do with the two. Or simply write a function and pass the function. It doesn't have to be lambda. Remember, this is a function wrapper. You can pass any type of callable object to it that receives 2 employees and returns a Boolean. It doesn't have to be a lambda. That's why I started with that. So you know all these things work magically. And it's a beautiful thing, actually. We good? Yes. The transform. So transform receives a range where it's supposed to do something from here to here. Then applies every single element of this one to the corresponding elements of this one using the operator you gave it. So it makes E0 multiply by taxes 0 and puts it in owing 0. Then E1, taxes 1, owing 1. Okay? Again, those could be any containers as long as the operation. So again, I put over here multiplies. You don't need to put multiplies. If you want to extract their names, for example, and put the names only in a vector, what would you do? Very simple. You simply, the only thing you need to do, that multiplies thingy, or I don't know, whatever you get, that multiplies thingy should be a function that receives whatever you have in here and applies it to here and gives it to here. Any function. And depending on what it is, so you wanted to add something to their name or do whatever you want to do, as long as this function over here accepts this one as left operand and this one as right operand, returning what's in here, it would work. In our cases, because I casted them all to double, life is beautiful. It just cast this one to double, and because I actually use multiplies to double, it expects double, therefore it casts every single element to a double. Try it. Go at home and play with it. You should, of course, anything. And makes your life so beautiful. I'm telling you, like shortens the time of implementation by tenfold. Okay? Go through the list. They put that's why one of the reasons that I don't like that thing of ours much. Let me see if it goes over there. It's gonna. I hope this it works now. Please, please, please. Yes. So if you go to algorithms, you will see that there you go. It gives you, like, these are queries. So it says over here 3 different ways: queries, modifiers, manipulators. Classifies them. All the queries, there you go. All of, any of, range of, for each, find if not, count if, all the things like that. Modifiers, copy if, transform again, fill n elements, how many of the things are supposed to be filled in. Replace if, replace. The name explains what it is, and when he says forward and later, these are essentially means this is just an iterator at the beginning, iterator at the end. What is the function that's going to be passed to it, and what is the constant value that is going to be replaced. So it explains exactly what. So any place that you see an fn, it's just a function. Any place that you see a const, it means it's a value, and it's self-explanatory. And if you don't know how it works, just simply, seriously, go to ChatGPT, say, how fill underline n works in C++. It explains it to you perfectly, okay? Manipulators, sort, and, I don't know, merge, and things like that. Anyways, that's that. Any questions? I'm not going to go through files because we had enough information. Now, I don't think even it's time for I thought I had it in here. Let me see. I don't think we are supposed to actually touch files before the break. And Monday is holiday, right? Okay, so we are good. And you have Monday, right? Yeah, so I want to make sure that we're not going to be falling behind. Give me 2 seconds. Let me just look at the... Not studying. Oh, shoot. And then, where is it? Oh, I have to log in. Sorry. There we go. So... No, we're good. We're good. We are completely, we have covered everything for the first half of the semester. So you don't have a class on Monday, no sweat. We are not behind. You're just going to come for the test. And yeah, we're going to continue with algorithms. Oh, we were not supposed to teach algorithms. Oh, so we are ahead. So anyways, we're going to review the algorithms after the break. All right, anyways, so we're good. We're good. I didn't know. Okay, we are a little ahead. That's fine. Any questions? Suggestions? Objections? Next Friday, you have your test. Only programming, and you have all the questions. We have 15 minutes, so if you don't want to come up, not 15 minutes, 5 minutes. You want me to go through the tests if you have any questions, if it's 5 minutes to ask, or you want to join at 10 o'clock? Okay, so let me bring it up. If the question is not answered, join tomorrow. Otherwise, so you'll be given a code for a function. So I'll give you a function. I'm going to say convert into a lambda. And I'm going to say this is a function. It receives these arguments, right? Then I'm going to say convert this to a lambda, remove these arguments, and instead capture these values as the neighboring values. So to see if you know how to capture by reference and by value. Then convert the original function into a functor, create it stateful. So I'm going to say that function that you had, now make it a functor, and for example, count how many times it's called, something like that. Okay, so it becomes stateful. Then I'm going to ask you to create a function pointer that can hold the address of the original function to see if you can create a function pointer. That's all. So that's the first one. For templates, I'm going to ask you, first of all, to write so I'll give you a function template, and I'm going to say specialize it for this type, to do this. So you have the function template, you write a specialization for it. I'm going to essentially ask you to create a wrapper. Okay? So I'm going to ask you to, but not a tough one. I'm just going to ask you to hold the dynamic version of an object and apply rule of 5 to it in a template. Okay? To see if you can do rule of 5, you can create a template. And it's going to be so essentially, I'm going to say microphone. You're going to create your template should be able to hold a microphone by address dynamically. Copy it, hold it, destroy it, rule of 5 and everything. And write a helper function to insert your template into an object to see if you can write a separate function as a template that passes another template to it. So you are essentially overloading the insertion operator. You did that in OOP345, but as a template. And finally, I'm going to ask you to write, I'll give you a class, and I'm going to create a composition of this class. Go read what composition is. You need to do that for me. Okay, you create the composition of a class, and I'm going to say the composition of a class is supposed to hold 50 things. If they're attempting to put more, throw an exception. You have to create your own custom exception to throw that exception. Then I'm going to ask you to write a code snippet to try and add something to that composition. So the question is there. So essentially, I gave you the sample question over here. So, and of course, you're going to agree to all this. If you don't, then you know what it means. So if you see over here, practice question is essentially, there you go. That's car, create a simple yada, yada, yada. That's the question. Okay? So you're going to get something like this. All right? No reference sheet. Your smart stuff, everything's going to be taken from you. It's you and a screen. Okay? All right. Done? Are we good? It's only coding. After the break, you're going to do the concept. So the first day you are coming for your lab after the break, which is going to be 2 weeks after your test, you're going to do the concept. Okay? And the concept is on the first 5 weeks. Just go through the notes during the study break. It actually forces you to study during the study break, so I'm happy. Okay? You have to actually study. So go through the notes and the concept. The concept question comes from the notes and the text that I gave you over the stuff, the comments that I put at the top of my code. Okay? These are the things that it's going to come from. That's it. Have fun and have a beautiful, wonderful day. Bye, people at home. Okay. End meeting for all.